Hello, my name is Zack, and I also work here. So I've been learning a lot about Elm lately, and a couple months ago, I actually finished a huge Elm app that I had been working on for about 4 or 5 months. And so my idea behind this presentation was, at first, I was just going to show you this app, but it's just so massive and so huge that I was like, well, maybe it's going to take away, because it's so complex. It'll take away from what's nice about Elm and what I want to show you about that. So instead, like a couple weeks ago, I was like, you know what, I'll just make a new app from scratch. And that was a bad idea, but I kind of have a demo to show you today a little bit, so that'll be nice. So basically, it's kind of like Scrabble, but I can't say it's Scrabble because Scrabble is Scrabble. So I'm going to call it Scribble. So we'll do a little bit of scribbling today later on. So first of all, so we're going to be talking about Elm today. And so you might be thinking, wow, this is blasphemy. We are at a JS meetup. What in the world is this language called Elm? So has anyone ever done Elm? Have you heard of Elm before? Who's heard of Elm before? OK, cool. So looks like a lot of you have heard about Elm. So how many of you here have done functional programming before? Cool. So it looks like a fair amount. So just a brief overview of Elm. So what is Elm? Elm is a language. It's a functional language that compiles down into JavaScript. So you can write your apps, your front-end apps, in Elm. They'll compile into JavaScript, and then you can run them on the browser. So what's nice about Elm? There's a couple of things. So it's strongly typed, which is not always a benefit, sure. Especially if you're used to languages like JavaScript. Coming to a strongly typed language could be quite a learning curve. But I would argue that Elm's type system is very nice, much better than languages like Java, and it could actually help you drive your application development in a way that's sustainable and also makes it easy to change later. Another thing that's really cool about Elm is it enforces immutable data. So you cannot have a variable that will just change out from underneath of you, like you would in JavaScript a lot. And also it enforces, so things like undefined is not a function that you run into all the time in JavaScript that will not happen in Elm. And then, so a few other things that we'll get into today that also I think makes Elm very nice. Their punchline is, hey, we're Elm, we have no runtime exceptions, which is not necessarily true, but you have much fewer exceptions than you would have in a JavaScript app, just because of the static typing and some immutability guarantees and things like that. So there's a couple ways to get your app to crash in Elm, and I'll talk about those a little bit later, but probably not an issue when you're first starting out. All right, so for those of us who have not seen Elm before, I want to do like a little bit of a tour of the syntax and like what it looks like. And if you're used to JavaScript and Java and languages like that, it may look very strange for you, so please feel free to stop me at any time, and we could talk about the syntax and how everything works. Sound good? OK. So here's my awesome graphic for a whirlwind tour of Elm syntax. OK, so the first thing that we're going to look at is lists. So in Java, JavaScript, you generally use arrays. In Elm, they call them lists. They're slightly different in the way that they store the data in memory. Elm lists are linked lists. So let's take a quick look at how lists work in Elm. So you can define a list the same way that you would define an array in JavaScript. You get square brackets. And I could say, like, hey, I have a list with a 1. And so Elm tells me, hey, you have a list with numbers. Cool. You could also do it with, like, a string, right? Helcope. Hello. All right. So that's pretty cool. So this is just very basic. This is what a list looks like. So since Elm is a functional language, you do not have objects. So you can't call methods on this object, right? So if you had something in JavaScript where you said, like, here's my list, it equals 1, you might say, like, list dot map or something like that, right? Or you might do, like, list 0 to get the first element out. That's not a 0. So things like that will not work in Elm. Instead, they have a bunch of functions available for you to work on the lists. Those functions will return a new list for you in most cases. Sometimes they turn different things. So let's take a look at some of the kind of standard things that you might see in a list. So first, we'll define a list as, let's call it list 2. It has 1, 2, and 3. So that's a pretty cool list. So what if I want to like double every number in this list? What would that look like? So if you're familiar with JavaScript arrays, you have array.map. Same thing in Elm. You could have list.map. It takes 2 parameters. The first parameter is an anonymous function, which looks like this. And it's going to take a number. And we want to return number times 2. OK? And then the second parameter here is going to be the list. OK, so does this look confusing for anyone yet? Syntax is a little bit weird. All right, so I was talking to a few other people who are learning Elm and like talking about how the syntax looks a little bit weird. So in a lot of languages, when you call a function, you put like a dot, and then you have parentheses, right? In Elm, you give your parameters by spaces, right? So I have list.map, there's a space. So that next thing in the parentheses there is my first parameter. The second thing after the next space is my second parameter, right? So this is going to go through the list and multiply those by 2. So we get 2, 4, 6. All right. So everything good with that? OK. Also important to note, this list that it outputs here, that is not the same list just changed. It's a whole new list, right? OK, so let's take a look at some other things. You could do list.filter. Again, this is going to take an anonymous function with a number. And let's say, like, I want my numbers not to be equal to 1. Okay. Is that not equal? So not equal is a little bit strange. It's this slash, whichever way that slash is, and equals instead of bang equals. So it's a little bit strange, but so that's going to go through my list and be like, let's get rid of all the things that are not, or let's keep the things that are not equal to 1. OK? You could do some other things. So you could say, I want to know if I have a 2 in this list. So you could say list.member 2, give it the list as the last parameter. It will say true. How about list.member 495,000? Ah, it's false. Too bad. OK, so these are some basic functions. You'll use these all the time in Elm. So you get lists all over the place. We'll talk a little bit about HTML later. HTML in Elm is written with functions. Each function takes 2 lists as parameters. So you get like an attributes parameter where you define classes, and you get a children parameter where you define like children divs or children spans, whatever you want, right? So there's one other thing I want to touch on with lists. They have this really weird operator that is just 2 colons, and it'll attach something onto the front of the list, right? So let's say I want to attach a 0 to my list 2. I can do 0 colon colon list 2, and I get a new list with 0, 1, 2, and 3. OK, so any questions about that? Hi, James.
So the reason it puts it on the front is because it's a linked list and it's optimized to append versus append versus.
Yes, so that's a very good point. So this operation, when you're putting something on the front, it's more efficient because you can just append it right on. If you want to append something to the back of the list in Elm, since they're not like arrays in JavaScript, the way that they work in memory is a little bit different. It has to just loop through every single element in your list and then finally attack it onto the end. So if you have a really big list, it's not going to be that efficient. You want to append most things onto the front. And since you brought that up, if you do want to add something to the back of the list, you could use the ++ operator, and you have to give it an extra list. So let's say append the list with 4 to that list too. So now I have 1, 2, 3, 4. OK. There's some other functions too that you could use in the list module. All right, so thank you for the question, James. Anything else? Cool. So let's go look at the next thing that I have in my whirlwind tour. All right. So is anyone familiar with tuples from other functional languages? OK, cool. So let's take a quick look at those. These are fixed length collections. So you can say, like, I have 2 elements in my tuple. That tuple will only ever have 2 elements. It won't grow by any more. So let's define one. So I have a tuple. In Elm, they go into parentheses to define a tuple. So I can say I have a tuple with a string that says hello and maybe an element 1. What did I do? Oh, I had an extra parentheses. OK, so the tuple type in Elm, you use these a lot, and they'll come in handy for something that we'll look at a little bit later on. But they're defined within parentheses and comma separated. Right. Yes, Chris?
I noticed that tuples can obviously have different types. I forgot to ask,
Yes.
but can lists have, do they all have to be the same type, all the members of the list?
Yes, so with lists, all the members of that list have to be of the same type. There's kind of ways where you could define new types that will allow.
A union or something.
Yeah, you could do a union,
Spoiler
but
alert.
yeah. But yes, that's true. So with tuples, you can have different types of elements in that tuple. Okay. So those are cool. They'll come in handy later on as well. The next thing, so records. That's a really cool record. I like that picture. So in JavaScript, you have objects. In Elm, you have records. And they look pretty similar, but a little bit different. So I want to just take a look at what a record would look like. So let's define like a person record or person object. So we'll say person equals. You define them in curly brackets, just like you do JavaScript objects. And then you'll say, I don't know, a name. And instead of colon, you would use a colon in JavaScript. You'll use equals. Yes, Alex?
Can you bump that up to the top of the screen?
For sure. How's that?
It's maybe a function for us to work with.
Is that good? Cool. All right, so I've got a name. My name is Zack. Age equals 31. OK. So you can see in the feedback here, it prints me back the object or the record with name Zack, age 31. You can see on the right-hand side, that's the type annotation for that. So your age key in that record is a number, and the name is a string, right? And so when you use that later on, you have to abide by those types. Elm is going to check that those types are accurate. So if you want to update a record, they have some maybe weird-looking syntax. I have this record called person, right? Let's say I want to change the age. So inside of curly brackets, you give the name of your records and then a key that's available there. So on my next birthday, I could do this. OK. So this is how you update records in Elm. You'll use this syntax here. It's also important to note that it returns not the same record. It returns a brand new record, right? So you're just redefining your record every time that you use it. All right, so any questions about records? Yes, Sanjay.
So if you call person now, it's going to return age 32?
I don't think so because I didn't redefine it.
Just verifying.
Yeah, so if I wanted to do that, I would have to say person. Well, that's not going to work because it's already bound.
So you're asking for a new record with the same data as person except an updated age?
Yes, that's correct. Yeah. So Elm doesn't let you do that. So I would have to define a new variable like person2, I guess. I like bad recursion. It's fun. OK. So now I have a person2 variable with my updated age. So in reality, when you're actually working in Elm programs, you won't actually do this a lot. There's not really a need to do this and defined it in a new variable, you'll just return it from a function. Okay?
I love that description of the error.
Yes, so the compiler is amazing. If you haven't ever seen the Elm's compiler errors before, it tells you pretty much what you did wrong. And it's like, excuse me, sir, I believe that you are mistaken, and here is what you should do now. So, yes?
Can you add something like an email to the record? Like after it's defined?
After it's defined, you cannot. Yeah, so JavaScript has a little bit more flexibility. Elm will check for your types. Usually what I do in that case is there's a trick where you can say, I want to redefine it into a different type. And then you could give it a type annotation, which is a little bit complicated. And I'll take a look at an example in a minute. But yeah, you can define it into a different type that will let you add fields that you might want to add to it. All right. So good question so far. Anything else about records? Yes, James?
Just kind of the variable when you try to reassign it, single assignment is a thing, right? Like you can't say x equals this thing and now x equals this other thing.
Exactly. Yeah, and that goes back to the immutability that we were talking about. So Elm enforces immutability, and once you define a variable, you cannot change it. It stays that value. Yeah, let's go back to that. Maybe you are trying to mutate a variable, Elm tells me. Elm does not have mutation.
Equals and then set it to something else instead of using person. Yeah. Well, it won't be that one. Person has a type.
Yeah. So it's given a type, and it won't let me redefine it to a thing that has a different type now. All right. So let's see what's next on the agenda. The case statement. Case statements are a big part of Elm. So they work a lot like switch statements in JavaScript, and they might be a little bit different in the way that they work. They allow pattern matching to happen. So unfortunately, in the REPL, I can't show you any good examples of case statements because the REPL is not smart enough to do that yet. So I'll try to show you case statements that, let's see, what's a good one here? All right, so every Elm program has this update function where it takes two parameters. It takes your model, which if you've ever done Redux before, your model is essentially your store. That's where you keep all of your data. And a message is, it's similar to what an action would be in Redux, if you're familiar with the Redux architecture. So messages, usually in the update function, you will do a case statement on your message function. And when you do that, you can match on the messages that are coming in, and you could also capture values that are coming in those messages in a variable. So inside of this current time branch of this case statement on line 82, there's a time value that's coming in. That's an integer, and I'm also capturing it in a variable right there. So on line 82, I'm both defining the variable time. That's going to be available to me in this scope, and also just doing the pattern match there. So those are used all over the place in Elm. All right, so Elm has currying by default. So of course you can do currying in other languages. So I think currying is better demonstrated by showing an example rather than telling you what it is. So let's define a function, okay? So we'll define an anonymous function that takes, let's see, I guess a name and an age, and then let's return a record that has name equal to name and age equals to age.
Can you pump it at the top again?
Oh yeah, sure. Sorry about that. Cool. All right, so actually I need to define that. All right, so I have a function now. This function should take two parameters, right? It should take a name and an age. So what happens if I just call it with like one parameter? What if I just call it with my name? So what that does is now it has returned me a function. And it's returned me a function that now takes one parameter, and that's an age parameter. So I can just say, let's see. We'll call this func2. Seems like a good name for it. OK, so I have func2 now, and func2 can take an integer. And so now it gives me back a record with my name, Zack, and my age, 31. So in other languages, you would have to like actually explicitly return a function that takes in that extra parameter from that function. In Elm, you don't have to do that. This happens by default. If you don't give it all the parameters that it needs, it's going to return you a function that's going to take the extra parameters that it's waiting on. And it's a bit confusing at first. It's very tricky, but once you get a hang of it, it's used in many places in Elm, especially the way that you build programs up. You'll rely on this fact. OK, so yes?
So then at that point, could you call func2 with 32? You get a new name is Zack, age is 32, and that's a new record?
Yes. Yeah, so I can call it again, and it will just return me a new record at this point. Yes?
You can also pass a function that does something to calculate age, right?
Yes. So if I did something like, I believe so. Let's find out. We'll just do a, well, 30 plus 2 would be a function by itself, right? Yeah.
Is that an expression?
30 plus 2 is an expression. Yes. OK, so that's currying. All right, and anonymous functions. So anonymous functions, we already talked about anonymous functions. And just a quick recap of what those look like. You open parentheses, you need a that's a backslash, right? OK. Thank you for the affirmation. I was worried about myself for a second. And then you can define a parameter name. Say it just takes one parameter name. Here's my param. So the body of this anonymous function is going to be here. So I can just say, like, just return me the param. Do nothing with it. And that's a function going from type A to type A. The lowercase type parameters are type variables. So you could fill that out with any concrete type that you want. Say, like, type integer to integer, or type string to string. The only requirement there is that those types remain the same, right? It can't take an integer and return a string or something like that. OK. So I think that was all for the whirlwind tour of Elm syntax. So any points? Yes?
What you just said reminded me, can you cast variables in Elm, or is it just you have to deal with it? Like, can you cast it on a string?
I have not done it personally, and I'm not sure that you can.
It seems like that you shouldn't.
Yes. I'm not positive that you can. My hunch would be that you can't, and you have to deal with it, but I'm not 100% sure on that.
You write a function that takes a type and returns a different type, right? And then assign that to a variable. You can't change the type of the variable.
Yeah, and that's generally what I do. Yeah. So, yeah, that's a good question, though. Anything else? Yes?
How would like sorting a list work? Such as like, do you keep it sorted if it's a linked list and then insert, or do you always like do that right before you update, or like as you update?
So generally, I would do it as I update. So when you're adding stuff to a list, generally you're either adding it to the very front or the very ends. If you want it to be sorted, then wherever you want it to be sorted, you would sort it right before you return it there. Yeah. Some good questions. Anything else? Cool. All right, so let's talk about how to actually do things in Elm. So Elm comes with this thing. It's built into the language called the Elm Runtime. And I have a sweet little graph that I didn't make, and somebody else deserves the credit for this, but I'm not sure who it is. So in Elm, you start out with a program. So every Elm program has a main function. There's different variations of these depending on how big your app is. But generally, it'll have three things, three important things. You have a model, which contains your data, right? And again, like I said earlier in Redux, this would be like your store. You have a view function. The view function takes in your model, and it spits back some HTML at you. And then the next thing that you have is your update function. So in Elm, they have this idea of parameterized HTML, which sounds really scary. Essentially what that is when you define your view function, you say, I have these messages that I want my HTML to be able to release or to emit. So like when you click a button, it's going to release something to eventually your update function. Or if you do an HTTP request, you say when this comes back, emit this message for me so that I can respond to it, and then I can update my model appropriately. So within that, you're in charge of pretty much all this stuff up here, right? You're in charge of defining your message. What messages do you want your application or your program to be able to release? You have your update function. How do you want to respond to the update messages that you receive? How do you want to change your model? How do you want to change your view? So your view takes in your model, and based on what your model is, the state of your model, your view is going to change, right? And then your view will, again, spit out some HTML. And they have this other idea of things called commands. Commands are essentially side effects. So if I want to make a request to an HTTP server, I have to tell the Elm runtime that I want to do that. It doesn't let you do side effects in your code. Essentially, you describe what you want to do, and then you hand it to the Elm runtime, which is running beneath your program, and it will actually go out and do those side effect things. So it'll go actually make the request, get the data back, and then it will pass it back to your update function, and you'll respond to whatever message it sent you back, and update your model accordingly from there. So we'll take a look at the different pieces a little bit. All right, so the model is your one source of truth in Elm. Let's take a look at what a model looks like. All my pictures got cut off, so they're kind of terrible. All right, so generally in an Elm program, you'll have a main file, usually main.elm, where you define your model. So since we're playing Scrabble, I came up with a bunch of things that I wanted to add to my model and keep track of. So I have a tile bag, so that keeps track of all 100 of my tiles that are available at the beginning of the game. Drag and drop config is stuff that you don't really have to worry about. Leaderboard is just essentially a list of scores of the top scoring players. Channels is something else that you don't have to worry about for now. But some other things that you'll notice there is like I have a score. I want to keep track of what my score is personally and my username. And then I have a few other things that are just kind of view related. All right, so any questions about the model? And again, it's just a record, right? Yes, Sanjay.
This might not be the right thing to talk about right now.
Sure.
The navy tile for line 33.
Oh, that's an awesome question. I'm glad you asked that. So I think one big thing that we run into a lot in JavaScript world and other languages like Java is that you like have null pointer exceptions and everything blows up and it's terrible. So Elm will not let you have a null value. There is nothing that can be a null. So instead they have this type called a maybe. Yes. So a maybe can only take on two values. It could take on a just and then a value. So for example, we'll say, here is a number equals just. Cool. So now I have a maybe number, a maybe number. Oh man, I have nothing. So nothing is the only other value that a maybe type can take. So either you have the value or you don't. And to use that value, the way that you would do that is you run a case statement on it. So you'll say like case, here is a number. Say I don't know, like maybe this is a value I got back from an HTTP call. I don't know if I actually have that value or not. So I'll say case, here is a number of, in my case statement, I will match on the just branch. So if I have just, I know I have the value, and then I can return the value by itself from there. If I have nothing, well then I have nothing and I need to respond accordingly. But Elm case statements, they're comprehensive. You have to have every possible branch covered. You can just have like an underscore wildcard character if you want to not cover everything, but not recommended if there's only two values that something could possibly take. But yeah, that's one thing that's really cool. And this is one of the reasons why you don't have undefined is not a function problems in Elm. So that was a good question. OK, anything else? Cool. So let's see, what's next? The view. So here we'll talk about some weird-looking HTML. Your view functions, like I said earlier, they'll take in your model. I have a view function here. And so div is just a function, right? It takes a list of attributes. So I'm defining the class name. The class name is Scrabble. And then you could see that this list begins on line 191 and ends on line 199 or 200. I'm not really sure. 199. So everything in that list are children elements. And this is how you build up your views in Elm. There's some other things. So as I mentioned earlier, it's parameterized on message. My HTML can emit values of type message. My message is defined right here. So it can only ever emit these values. It can't emit anything else. So I'm not actually emitting anything from here, but I have some subviews that if you look at scoreboard, there it is. So I have things like, for example, on click. You could pass in simple event handlers like you would in JavaScript on click. And you say, when you click this button, submit this message. And you could see in my main function here, I'm passing in a message of submit score. So if you click on the get score button, it's going to emit a message to me of type submit score. That's going to return to my update function. I'll catch it right here. And then go down to your case statement where it submits score, and then I could respond to that appropriately. Right? So that's how views work in Elm. So update function we just kind of looked at. So as I said, the case statements in Elm, you have to cover all possible branches. So I have all branches of my message function here are covered, and I respond to them by returning a tuple. And this tuple has my model. So that model is going to be a new version of your model. Generally, you'll update it based on what happens. This other thing is a command message. So this is where if you actually want to do something that's like a side effect, if you want to call an HTTP server, you generally will not update your model. You'll just return your model as is. And then you say, I have this command. I want you to run Elm. And then you just give it to the Elm runtime. It'll go actually call the server, and it will return another different message. And you could use that message and the data that that message has to update your model accordingly. Yes?
Can you give some examples of like when this would happen in Scrabble? Like
Sure.
for Scribble?
Scribble, yes. So let's get to an example right now. Here we go. Just starting the server up. Where's my Scribble app? Here it is. Cool. So my name is Zack. Oh, no. All right. So I'll walk you through, in a second here, I'll walk you through the messages that this is actually emitting and what I'm doing to respond to them. So the first one is, I have this word row here. If I click on get score, it updated appropriately there. All right, so the way that that works, so when I click on that button, get score, that's going to give me a message of type submit score. And so what I'm doing here is I'm validating that the move that that user is trying to submit is valid. And if it is, it's going to return me this thing that says OK. And inside of that OK, I have wrapped a command that's actually going to go call the HTTP server. So from here, I'm returning my model. I'm not updating anything there. And it's going to call the command. Inside of the command, if it's successful, it's going to return me another message called update score. OK? And update score comes back to me right here. I can look at the result. If the result was a successful result, I get an OK. Inside of that OK, I have a Scrabble response wrapped up inside of that. And then I update my score and a few other things. I update the tile bag. I update my messages based off that score, or the Scrabble response there. If the HTTP call errors out, I get an error. It could have some different values inside of this. I'm using the underscore just to say, like, whatever value, I don't care what that is. There was an error. And I'm not really doing anything here. In a more production app, you probably want to respond to that in a different way. I'm just returning my model and saying, don't do anything. So command none says don't do anything. And generally, you can see in most of my update functions, I have a command none. I'm not actually doing anything side effecty. I'm just updating my model. OK? So.
What is your context, like context manager.update? Is that kind of like pull apart the Scrabble response record? Is it the right word? I don't know.
Yeah, so record is the right word. So a lot of the times in your main update function, you'll get like this huge case statement and a lot of complexity. So I try to, what's the word for it, encapsulate some of the updating logic that goes on behind that into different modules. And this is just taking my model, the Scrabble response. Based on that, it's going to return me mostly a new update, or a new, what's this called? A new Scrabble record. It has some different fields. And the reason it has different, so the reason I'm calling like updates.score and updates.context is because it doesn't have all of the fields that I need for my model function. It has a subset of those. OK? All right, so very good questions so far. Any other questions? Cool. Let's go back. All right, so we kind of touched on messages here, so we'll just skip over that a bit. The next big part of Elm that you'll run into is a thing called union types. So your message is a union type. The maybes that we looked at earlier, it's a union type. I want to show you just a quick example of how you would define those. All right, so you define a new union type by using the type keyword, and then you give the actual type a name. Underneath of that, you set equal. This is very much like enumerations in Java or a lot of other languages. The difference is they can also capture values inside of them, and they can carry those values around. And they don't always have to be of the same type. So here I'm defining 5 different states that this type can be in. It could be no move detected. This is used to validate whether a move is valid in Scrabble or not. Possible move found. that value will also carry with it a list of tiles. And so you can use these in pattern matching, and it's a very easy way to kind of say, these states are impossible. I don't want any states that are not related to this to ever happen. So it keeps your app more consistent, I think, over the long run. It also helps you with when you're refactoring and going back through. If you're missing or you're trying to add types that don't belong, it'll tell you, the compiler will tell you right away that you're doing something wrong there or you're missing something. All right, so union types they were, for me, I think the hardest part of Elm to grok. I didn't really understand them for a while. I still don't know that I fully understand them very well. I found a couple use cases in the last couple of weeks where I found that they were actually really powerful and they helped out a lot. But definitely, if you're just coming down, that'll be a big, I think, learning curve for a lot of people. All right, so HTML message. We talked about this. You have parameterized HTML that can shoot off messages. Command messages, so your commands can also emit messages that your HTML told it to emit. And so there's another thing that we haven't really touched on yet. There's a subscription, and those are defined as sub messages. So if you get into a more complex program, you will want to have some subscriptions. Those are generally defined in a subscription function here. I'm just connecting to a WebSocket. So I subscribe to a WebSocket that I'm connected to. The WebSocket is going to send me messages. And I can look at those messages, and the Elm Runtime will throw those to me wrapped in a message that I've defined. Right? So those will also go to my update function and let me update my model based on what those messages are. All right, so any questions about subscriptions? Cool, all right. Next.js interop. So this is a big thing in Elm. So there's some other languages that are competing with Elm. There's a language called ReasonML, and they're very similar. Where they differ is the way that they interop with JavaScript. So Elm made the decision up front that they will not let you call JavaScript functions from your Elm code. That's not a thing. So if you have a big JavaScript app and you want to add some Elm in, what do? Right? So they offer this idea of ports. And there's two kinds of ports. There's incoming ports and outgoing ports. So outgoing ports are where you say from your Elm code, you say, hey, I have this data, JavaScript. I want to give you this data so that you can do something with it. So you can throw JavaScript some data from your Elm code, your Elm program, and JavaScript can do whatever it wants with it. The incoming version of ports are essentially they're subscriptions in your JavaScript code. So, subscriptions in your Elm code. And so what those do is maybe you have like a third-party package that you really want to use in JavaScript. You can tell JavaScript to send your Elm app some updates or some data. And you have to actually give those data types in Elm, and you have to decode them. So it's a little bit complicated. And when you're first coming to Elm, this was a huge frustration for me. Right? Just giving everything in JavaScript where you're just allowed to have whatever you want, wherever you want. When you give that same data to Elm, all of a sudden you have to check the types. You have to make sure that these things are valid. You have to use JSON decoders to decode them so that you could actually use them in your Elm code. But then the more I thought about it, or the more I listened to kind of the design behind these, the more I kind of understood it. So Elm was not originally designed to be a compiled to JavaScript language. It was a language that was designed to be a good language to build UIs in. So at some point in the future, if you have your whole community just calling random JavaScript functions in different packages all over the place, and you want to go to a different platform at some point in the future, maybe you want to go to WebAssembly. Well, then if you have this JavaScript code all over your packages, all over your code base, you can't make that transition as easily. So what they're trying to do here is just decouple Elm as much as possible from the compile target, which is JavaScript in this case. Right? So they're trying to be agnostic in the long run, even though right now, obviously, JavaScript is a huge thing. It's really the only thing that Elm does well right now. Okay. I'll just give a quick look at what these actually look like. Let's see. What? That one. So in my Scrabble app, I don't have any JavaScript interop. It's just straight Elm. In this app, which is a bigger one, I do have some ports that I'm using. So you have to define a module in a special way. You use the port keyword that says, hey, I'm exposing some ports to JavaScript here. What you do is you'll say, I have this port function. For example, log out. So log out, I'm actually doing stuff with session storage in JavaScript. So I'm just erasing that session storage. That's going to be a command message. And let's see. In an actual JavaScript file, I have an LMAP object, and that exposes a ports key. And then those ports have those things that I define in those port files. So there's store session, logout, for example. I'm subscribing to the logout message in my JavaScript, and then just removing session from my local storage. That's the way that you would do an outgoing thing, right? So from Elm, you're saying, hey, JavaScript, go do this thing. You have to subscribe. The opposite end of that are the incoming. So incoming to Elm, instead of subscribe on your ports, you would do a send. So I'm sending a response to my Elm app from JavaScript. Okay, so this is, I think, a very confusing point, kind of frustrating at first, especially if you have a lot of JavaScript and you want to use that in your Elm app. It can be a little bit frustrating at first. It might be a big wall, but it does provide for good decoupling between Elm and JavaScript. So any questions about ports? Yes, Brian.
Can you access the window object from Elm?
I do not believe so.
Okay. Do they attempt to recreate like an add event listener API, or do you do all those types of things through ports?
So if you want to do something like specifically that JavaScript exposes, you would do it through ports. You could also use a function in Elm. So they have an events library where you can define custom event listeners. But those already have to be defined in JavaScript. So for example, in my drag and drop thing, there's like an on drop or on drag or something like that that's the DOM exposes. I can access that from Elm by using the events module and just defining events.on drag or drop or whatever. Does that answer your question?
Yeah.
Okay. All right. Anything else? Cool. So finish up kind of quickly here. There is another way to talk to JavaScript. This one's on program startup. You can use these things called flags. They're not entirely different from ports, but when you start your Elm app up from JavaScript, you're going to have to define it here. So I have my Elm app embedded inside of this Elm div in my HTML, and then I call this big Elm.main embed. I'm embedding my object here. This parameter to embed is a JavaScript object. You can pass this to your Elm program as a flag. So if you want some initialization stuff from JavaScript, you can pass those in as objects. You just need to define the types for those in Elm, and then again decode them. And then you'll have that when your Elm app starts up. Yes?
Can we see that being decoded?
Yes, I hope it's not too terribly confusing because I was learning Elm as I did this. And this is a massive file. Where is it? So this value, that's going to be the flag. It's a JSON value. I believe right here I'm saying set my session. I'm decoding the user from my JSON. I pass the value from here into here, and I get a maybe player. And it's a maybe player because I might not have a player that's stored in the session storage. So this is what a decoder looks like. This one's actually a little bit complicated. All right. We'll take a look at decoders as well in just a second. JSON. So very good segue into that. We'll just talk a little bit about these because we're running short on time. So a JSON decoder is essentially a way to say in your Elm code, like, I'm going to have these JSON types coming into me that I might be interested in. I want to decode those to types that are usable in my Elm code. So right here in this class, I have a type of entry. So this is a record with a user, which is a string, and a score, which is an integer. So I'm going to have those passed to me from a server response as JSON. So what I'm going to do there is say I want to create an entry thing. The map to is saying basically I have two things that I want to pass to this. And you could say decode the field in the JSON that you get back with the string or with the key user. Decode that to a string type. And then decode the field of score into an integer type. And then I have that produces a record with user of type string and score of type integer. So it's like a very basic decoder. They get much more complicated when you have bigger JSON coming back to you from different responses. But that's kind of a good place to start here. So any questions about decoders? OK, cool. So that was pretty much all. The last thing I want to say is just the compiler is awesome in Elm. So we saw a good example of one of the compiler messages earlier. The best thing about the compiler, though, is when you start to get these bigger and bigger apps, if you realize that you've done something wrong and you want to go back and change things or refactor. So in other languages, you might just have to remember things that might be broken or you might need to change from memory. It might have to fit all in your head. With Elm, when you're doing that, and I've had this happen to me a couple weeks ago, where I realized I was taking the wrong approach and I wanted to redo it. So I started refactoring, and the compiler was just telling me, hey, you have this thing over here of type this and type this. It's expecting this type. You should go change it. This is why your program is not compiling. It will guide you through your refactor in a way such that when you get done, your program just works. Granted, your logic might be wrong, but your program will run. It won't cause any runtime exceptions, which is really nice. All right, and that's all for today. So thank you very much for coming. Oh, and did you have any questions about Elm otherwise in general or other things? Yes?
Are WebSockets done reports also?
Actually, they're not. So Elm exposes a module called the WebSocket low level, which is pretty cool. I'm not exactly sure how it works mechanically, but it's very nice. Yes?
Speaking of those, I noticed using Phoenix in there.
Yes.
Is there a reason for that besides it being another functional language, or can you use Node or PHP or Python?
Oh, sure. You could serve your Elm app from whatever backend language that you want. So you can serve it up from Node, whatever you might feel comfortable using. I used Phoenix just because I love Elixir, and I think it's really nice. So I also wanted to hook it up to Phoenix channels. So that was my reason for that. Yes, James?
Could you demo a real short game?
Yeah, sure. So I noticed I was working with like Alex and John today. I have a few bugs that are still there, but that's fine. Well, I don't know what that letter is. Okay. Escape. All right. So what I had in mind was like I was going to set a timer of like 2 minutes and just allow people to connect over Phoenix channels and see who gets the highest score in 2 minutes. I don't think I'm going to be able to make a word here. Toe, that's a good one. right. For some reason, it hasn't taken my, my changes into effect yet. I don't know why that's happening. Anyway, on my latest branch, I have it connected to Phoenix channels, and like you can connect, and there's a leaderboard that pops up that says this person has scored this many points at this time, and it's awesome. You should try it. I have the GitHub repos up there if you just want to look at it for reference, if anybody's interested in getting into Elm. And I would also recommend the Elm Guides, elmguides.com, as a great place to get started and walk you through the basics of Elm and the Elm architecture in a slower way. All right, so thank you again, everyone.